Welcome to LCE Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LC Electronic, the world of printed electronics in one place. Sustainable development in electronics manufacturing, how printed components support the environment. In today's episode of LCE Insider, we take a closer look at sustainability in electronics manufacturing, and more importantly, how printed electronics, a technology that is thinner, lighter, and far more flexible than traditional circuitry, can meaningfully support the environment. We often ask whether sustainability is just a trend, or if it carries real business value. The truth is that in recent years, customers, investors, and governments have shifted expectations. They no longer ask only about the final product. They want to know how the product is made, where the materials come from, how much energy is used, and even what happens to the product after its life cycle ends. Printed electronics, often called PE, offer manufacturers a cleaner and more responsible path. They help reduce emissions, shorten supply chains, and minimize the consumption of valuable resources. A report from OEA shows that 42% of companies are planning to increase their investments in printed electronics in the next 2 years, mainly because the technology can support environmental goals. Some companies already using PE have reduced their carbon footprint and made their production processes more flexible. Quad Industries, for example, use printed electronics in medical devices and sports shoes, enabling them to create prototypes 60% faster while generating less waste. One of the biggest environmental advantages of printed electronics lies in the elimination of chemical baths. Traditional PCB production requires strong chemicals to clean and shape the boards. These chemicals are dangerous and create a large amount of toxic waste. Producing just 1 square meter of PCB can generate 5 to 10 liters of polluted water. In printed electronics, we only print what is needed: a conductive layer, a protective layer, or a dielectric layer. There is no chemical washing step. This means less material is used, less waste is produced, and the working conditions for employees are safer. Printed electronics also reduces water consumption dramatically, often by as much as 90%. Even better, PE can be printed on recycled paper, recycled plastic, or flexible fabrics. Pragmatic, a company that produces RFID labels, stopped using solvents entirely once they adopted printed electronics. For every 1,000 components, this meant 50 to 70 liters less wastewater. Energy savings offer another major benefit. Printed electronics does not require the high-temperature ovens used in traditional electronics. Classic methods may need heating at 240 to 260 degrees Celsius. Printed electronics uses inks that cure at just 120 to 150 degrees. This reduction can save up to 60% of the energy typically consumed during production. Faster printing methods such as digital or screen printing reduce total production time as well. Some companies like Tactarian cut prototyping time from 8 weeks down to 3. Others, like Quad, reported energy savings of almost 40% in a single production cycle. Printed electronics also allow products to be made lighter and thinner. Many PE parts are thinner than 0.5 millimeter and weigh less than 10 grams. This immediately reduces transportation costs, packaging needs, and overall environmental impact. Lighter parts also make assembly easier and often more ergonomic. And because printed components can be produced locally, companies do not have to rely on long shipping routes from Asia. FlexEnable in the UK, for example, now produces flexible OLED displays locally and reduced delivery times from 12 weeks to just 5 days. Schreiner Group in Germany manufactures smart labels with printed NFC antennas, reducing their transport-related electronics costs by 30%. Another important aspect is recycling and reuse. Printed electronics makes disassembly easier because components are simpler and more uniform. This enhances the recyclability of materials such as silver, copper, and various plastics. Many companies now follow the Design for Disassembly principle, which is at the core of new EU environmental directives. Some printed components can even be repaired instead of discarded. Researchers at Cambridge University demonstrated that printed sensors could be refreshed by printing a new functional layer on top. This approach helps reduce electronic waste, an increasingly urgent issue in Europe, where more than 10 million tons of e-waste are generated each year. For CEOs and senior managers, printed electronics also supports ESG goals. Environmental, social, and governance standards are no longer optional. They affect access to funding, partnerships, and market trust. Printed electronics help companies meet these obligations by reducing energy consumption, water usage, and reliance on hazardous materials. They also support compliance with certifications such as EPEAT, ISO 14001, and TCO. New EU regulations, like CSRD, require companies to report detailed environmental data, and printed electronics make it far easier to provide clear, measurable numbers. Prelonic technologies, for example, reduced energy consumption by 43% per printed circuit thanks to low-temperature curing inks. So what does all this mean for the future of manufacturing? Printed electronics combine ecological responsibility with economic benefits. They allow companies to innovate faster while reducing the environmental cost of doing business. They shorten supply chains, cut waste, and help build a brand that is both modern and responsible. More and more companies now understand that sustainability is not an expense, it is a strategic advantage. It strengthens the brand, increases customer trust, and improves long-term financial performance. Printed electronics support that shift with 4 clear benefits. They make it easier to comply with EU requirements such as CSRD, RoHS, and REACH. They increase production flexibility and reduce dependency on long supply chains. They save money by lowering the use of energy, water, materials, and transportation. And finally, they help build a brand that customers want to support, a brand that is innovative, environmentally responsible, and future-ready. At LC Electronic, we not only produce printed components, we also help companies understand the environmental value behind them. We support sustainability planning, documentation, and reporting. We show how printed electronics fit into ESG strategies and how they strengthen both environmental and business performance. Welcome to LCE Insider, your weekly insight into the world of printed electronics, flexible interfaces, and smart design, powered by LCE Electronic, the world of printed electronics in one place. This episode of LCE Insider was powered by LCE Electronic, where printed electronics meet precision engineering. Visit lceelectronic.com to explore materials, cases, and technologies we talked about today.